Welcome to all. Hello, dear students. I am Sagar Avale, working as a lecturer in Mechanical Engineering Department, CSMSS College of Polytechnic, Aurangabad. This is the third lecture on topic Simple Stress and Strain. After watching this video, you will be able to solve some examples based on simple formulas like stress, strain, Young's modulus or modulus of elasticity, and deformation, that is change in length. Stress, sigma is equal to P by A, that is force per unit area. Strain, E is equal to delta L upon L, that is change in length to the original length. Young's modulus or modulus of elasticity, that is capital E is equal to sigma upon E, that is stress upon strain. Deformation or change in length, delta L. As we know that Young's modulus is equal to stress upon strain. Now here put the value of stress, that is P by A, and value of strain, that is delta L upon L. Then the equation becomes like capital E is equal to P by A upon delta L upon L. After solving this equation, we are getting the value of delta L is equal to PL upon AE. These are the some important formulas that we are going to use to solve the examples. So, example first, calculate the minimum diameter of steel wire to lift a load of 8.2 kN if the permissible stress in the wire is 120 MPa. Here in this numerical, what is given? So given is here load is equal to 8.2 kilonewton, that is P is equal to 8.2 kilonewton. Convert this kilonewton into Newton, that is 8.2 into 10 raised to 3 Newton. After that, the permissible stress, that is sigma, is given here. So sigma is equal to 120 MPa, which is equal to 120 Newton per mm square. To find minimum diameter of steel wire. Now to solve this or to find this diameter, we are going to use the formula area A is equal to pi by 4 d square. By using this equation, we are getting the value of d. So as we know that stress is equal to P by A. By using this equation, first of all we calculate the area. So equation like this, A is equal to P upon sigma. Now we are going to put the value of P and sigma in this equation. Then the equation is A is equal to 8.2 into 10 raised to 3 upon 120. Therefore the area is 68.33 mm square. Now use the equation of area. A is equal to pi by 4 d square. So d square is equal to 68.33 into 4 upon pi. Therefore d square is equal to 87.004. Now squaring on both sides, we are getting the value of d, that is d min is equal to 9.327 mm. So the final answer is minimum diameter of steel wire 9.327 mm. Example second, a bar of cross section 20 mm by 20 mm is axially pulled by force P kilonewton if the maximum stress induced in the bar is 50 MPa. Determine the P if the elongation of 1.2 mm is observed over a gauge length of 3 meter. Determine the Young's modulus. Here in this equation it is given the area 20 by 20 is given. Here area is equal to 20 mm by 20 mm, which is equal to 400 mm square. Then the maximum stress induced in the bar is 50 MPa. So the stress is equal to 50 MPa. Then if elongation is 1.2 mm is observed, means change in length, that is delta L is equal to 1.2 mm over a gauge length 3 meter. This is the original length 3 meter. So L is equal to 3 meter. Convert it into mm, that is 3 into 10 raised to 3 mm. So what is to be find in this numerical, that is determine the P and Young's modulus. So to find P and E. So as we know that stress is equal to P by A, by using this equation we are going to find the P. So the equation is equal to P is equal to stress into area. Put the value of sigma and A in this equation. So P is equal to 50 into 400. So the final answer is 20 into 10 raised to 3 Newton. The value of P is 20 into 10 raised to 3 Newton. Now what is to be find? That is E, Young's modulus. We know that the Young's modulus E is equal to stress upon strain, that is sigma upon E. So first of all we have to calculate here strain. E is equal to delta L upon L. So put the value of delta L and L here. So the equation is 1.2 divided by 3 into 10 raised to 3. So the answer for strain is 4 into 10 raised to minus 4. There is no unit for strain. Now put the value of stress and strain in equation Young's modulus. So the equation is 50 upon 4 into 10 raised to minus 4. So the answer of Young's modulus is 120 into 10 raised to 3 Newton per mm square. So the final answer is P is equal to 20 into 10 raised to 3 Newton and Young's modulus is equal to 125 into 10 raised to 3 Newton per mm square. Example third. A steel rod 800 mm long and 60 by 20 mm in cross section is subjected to an axial push of 89 kN if the modulus of elasticity is 2.1 into 10 raised to 5 Newton per mm square. Calculate stress, strain and reduction in length of rod. So in this numerical what is given? L is equal to L is equal to 800 mm. Here the steel rod having 800 mm long. Then cross sectional area 60 mm by 20 mm. A is equal to 60 into 20, which is equal to 1200 mm square. Then axial push of 80 kN, that is P is equal to 89 kN, which is equal to 89 into 10 raised to 3 Newton. Then modulus of elasticity is given, that is E is equal to 2.1 into 10 raised to 5 Newton per mm square. So calculate here stress, strain and reduction in length of rod, that is delta L. So first of all we are going to calculate the stress. As we know that the stress, that is sigma, is equal to P by A. So put the value of P and area in this equation. So equation is stress is equal to 89 into 10 raised to 3 upon 1200. Therefore the stress is equal to 74.17 Newton per mm square. Now we are going to calculate strain. We know that strain is equal to delta L upon L. So first of all here we have to calculate delta L. We know that delta L is equal to PL upon AE. Here P upon A, this P upon A is nothing but stress. Therefore the equation becomes delta L is equal to sigma into L upon capital E. Therefore put the value of stress, length and Young's modulus here. So the equation is delta L is equal to 74.17 into 800 upon 2.1 into 10 raised to 5. So delta L is equal to 0.2825 mm. Now put the value of delta L and L in the equation of strain. Therefore the equation becomes E is equal to 0.2825 upon 800. Then the strain is 0.00035. There is no unit for strain. So the final answer is here. Stress is equal to 74.17 Newton per mm square. Delta L is equal to 0.2825 mm and strain is equal to 0.00035. Thank you.